Okay, I taught a lesson today in GCSE Electronics and a few people were having a problem with figuring out what value resistor to put here. So it is a bit of an elementary video, but I'm going to explain it, and then if you're in any doubts and you're one of my students, do please come to see me. A stable timer, so the output's going to go on and off, and the timer is powered by a 6-volt voltage source. That means that we can assume that the output of the 555 timer is going to go high, approximately 6 volts, no greater than 6 volts, and low, it's going to go close to 0 volts. The other thing that we need to know is that the LED has a forward voltage drop. If you were to look at the datasheet for an LED, you would see something like this, where voltage is on one axis and then we've got current here. And what you'll see is that we call it a characteristic curve for the LED, that the current stays very low until a certain voltage is reached. That certain voltage for a red LED is about 2 volts. It's actually probably more likely about 1.8 volts, but 2 volts is good enough for us. Once we get up to that forward voltage, that it more or less the voltage stays at 2 volts, but then the current increases dramatically. Now, if we put too much current through the LED, it will burn out. So we want to keep it within a range of something like that. With a traditional LED, they tend to be something like between about 10 and 20 milliamps of current. Newer LEDs can actually shine quite brightly on much less, maybe about 2 milliamp. But let's assume that it's going to be about 10 milliamps of current to light up this LED. Now the same current is going to go through this LED as the same current which goes through the resistor and is sourced from this pin as well. So it's all the same current. So let's assume that that is going to be 10 milliamps to light that LED up. And we've already identified that the voltage drop across this LED is going to be something around about 2 volts. So if we were to put a voltmeter or a multimeter across here and test the forward voltage, you would know that the forward voltage, you'd measure it as something around about 2 volts. If this down here is 0 volts and there's 2 volts of drop to get down to 0 volts, then up here must be 2 volts above ground. And let's assume that this is currently outputting high, so we said earlier that it's a 6 volt supply, so the output is likely to go close, although not exactly 6 volts, but it's good enough to assume it's 6 volts. So if that's 6 volts there, so we've got 6 volts on this side of the resistor, 2 volts on this side, so the potential difference across that should be fairly easy to see that there's 4 volts of difference. So now that you know the voltage drop across that resistor and you know the current going through it, then you should be able to calculate the resistance. So to do that we need Ohm's law, so V over IR. If you have any problem with remembering the Ohm's law triangle, you could if you wanted to. I just call this the Ohm's law chicken. There we go. Okay, that will hopefully imprint it in your mind. Okay, so we've got the beak, the V here, okay? So if we now want to calculate this value resistance, we just cover over the R, so R equals V over I. So R equals V over I. Well, V is 4 volts, but let's do it, let's go back a stage. So it was 6 volts minus the 2 volts. And then we said the current is going to be 10 milliamps. Which is, you could write it 0.01. You could, if you wanted, also write it as, you could do the same equation by saying R equals 6 minus 2 over, and it's because it's 10 milliamps, 10 times 10 to the minus 3, because 10 times 10 to the minus 3 is the same as 0.01. So 4 over 0.01, which is 400 ohms. Now if you were going to choose a resistor value, we won't actually have a 400 ohm resistor. Probably the nearest we've got is 390 ohms, and that will be fine.